One other thing that I might have been good to mention in the previous one to tie in like a previous video I made is this range function. So I could do another list. My other list is equal to range, and I'll say 10 here. And now I can say for item, for item in my other list, print item. And just because it's going to be easier, I'm actually just going to put this code up here, and when I run it, it should print out every item in the list. But there's a problem here. I guess not. Okay. So 0 through 9. Now, again, it starts from 0 and goes up to 1 minus whatever that number is there. So if I want all the numbers from 0 to 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I do this. On the other hand, let's say I want the numbers from 1 to 10. I would do 1, comma 11, and this starts at 1. So again, it's going to give me all of the numbers. It's going to start there and end at 1 less than that. Okay, but let's say I just want all of the even numbers from 0 to 10. So 0, 2, 4, 6, 8, and 10. This gives me all the numbers from 0 to 10. There's an optional third argument here that tells you how much you want to increment the list, or how much you want to increment the number each time. So if I do 2 here, it's going to give me 0. Add 2 to that, that's 2. Add 2 to that, that's 4. Add 2 to that, that's 6. Add 2 to that, that's 8. Add 2 to that, that's 10. And 10 is the last number that's going to be less than that, because if I add 2 to it again, it's going to be 12, which is bigger than 11. So now if I run this, it's just going to give me all of these numbers. On the other hand, let's say if I want to go all the way up to 12, if I put a 12 here, well, again, the next number is 12. 12 is not less than 12, and so it's not actually going to print 12. But if I want 12, I need to make this go to 13. Okay, so you can see what's going to happen. It's going to start at 0. That's whatever number here is going to be the first element of the list, and it's going to increment each item. The next item is going to be that number more, so in this case 2 more, up until you get something like it's going to do that as long as the output is less than, strictly less than whatever number you have here. So again, if I want to go up to 14, this isn't going to give me up to 14 because the next element after 12 is going to be 14. 14 is not less than 14, so we're just going to get that. If you want 15, has to be like that. Okay, and again, this is just a list. So my other list is another list, just like my list is up here, except you just created it a little bit differently. Okay, so now I want to talk about Numpy. So it's another package. So we're going to do import, and there should be an error when I do this. Okay, error, no module called Numpy. So I'm going to close out Jupyter for now. Sorry, I'm going to save it first. I'm going to close out Jupyter. Just going to close Anaconda as well. Open it back up. Okay, so I'm going to activate my environment. Math 696 S24. And now I'm going to do conda install Numpy. And so it's doing everything that it needs to be done. So I'm just going to do yes here and pause the video while it does the install, unless something interesting happens. Okay, so this is where we are here. I'm going to open, open back up Jupyter. And now that we've installed Numpy, everything should work properly. So this was week 2. So now when I run this, it should work. It's importing Numpy, so it's going to take a little bit longer to run this cell. Whoops. Okay, so everything worked properly there. Okay, so now we have access to all of the Numpy functions. So what we're going to do, again, so Numpy is sort of like a wrapper around these more basic Python arrays, which I don't want to get I don't even know if that's the best way or the most accurate way to describe it, but the point is, it's sort of under the hood, you're dealing with Python lists, but you have so many more functions that you can do on these lists, and we'll use some of them in the assignment today. Okay, so at any rate, just like like the list, we can create a list. There's several ways to create a list. One way is to convert a list that you already have, so something like this. One way is to convert a list like that into a NumPy array. So the things in NumPy are called arrays, and you can convert list to NumPy arrays. So I'm just going to say NumPy, let's see. I'm just going to say array1 is going to be equal to NumPy dot array, whoops, and I'm going to put my other list here, and I get the same thing. Whoops. Oh, I haven't run this line of code. So the problem is I didn't run this line of code, so this instance of Jupyter didn't know what my other list was. Okay, get the same thing. And now I could do very similar things to what I've been doing for other lists. So I could say something like for index item in enumerate AR1, I'm going to do something. I could say print AR like this, and when I run, I'm going to get a very similar thing to what I did up here, a very similar thing to what I have up here, though I guess it's AR1. That's what I called it. So, okay, so this is a very good way to iterate over a list that gives you access to both the index of the list and the item in the list, instead of having to like just iterate over the index or the things in the list and the index separately. This kind of zips it all together, and it's very helpful to do it that way. Another good thing that we can do, another thing that we have access to, is we can print the average. So 7 is the average of this list here. And we can do all of these other kind of statistical probability, and really we're not going to get to it, but a whole bunch of machine learning stuff with NumPy arrays. Okay, now we can also create NumPy arrays in a similar way that we created lists up here. So I'm going to say AR2 is equal to NumPy dot arange. Okay, so this is like range. And if I do 10, I'm just going to get the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And so now if I do for index, comma, item in enumerate AR2, now I'm just going to do print AR2 equals dot format. What am I doing? Index item. And when I run it, I'm going to get the same thing. Okay, again, if I want to do something like 1 to 10, it's going to be the first item in the list is going to be 1, but the index here is still going to be 0. And so I run this, I'm going to get that. And then now let's say I want sort of the odd numbers from 1 to 9. I'll do a 2 here, and I get this. There's another way to create a list in NumPy, and this is using, well, there's several other ways to create lists, and one is called linspace. So I'm going to do AR3 is equal to linspace. Whoops. So all of these functions, arange and array, these are functions in the NumPy package. So just like we had to do math.something, we have to do numpy.something here. So we're going to do numpy.linspace. I'm going to do 0, 1, and 10. And what this is going to do, this is going to give me an output. The first element of the list is going to be 0. The last element of the list is going to be 1. And there's going to be 10 elements in the list. Okay, so the first element will be 0, the last element will be 1, and it's going to give me 10 elements in that list. So now if I do this again for index item and enumerate AR3, print AR3 like this equals okay, so this is where we go. We start with 0, we end at 1, and we increment by, I guess 1/11th each time is what's happening here. Sorry, not 1/11th. I guess that's 1/9. Of course, if we want it to be 0.1, we just change this to a 9, and not a 9, 11 here. And now we're incrementing by 0.1 each time. Okay, and another thing that I want to mention, let's go back up here to this example. Let's go from 0, and instead of from 0 to 10, let's go from 0 to 2. With the range function, this number has to be an integer, but with a range, it could be a decimal. So I could, let's say I want to start at 0 and increment by 0.25 each time, all the way up to 2. So the output here will be 0, 0.25, 0.5, 0.75, 1, 1.25, 1.5, 1.75. The next term in the sequence would be 2, but that is less than this right here, so it's not going to include that. So if I run it, I'm going to get something like this all the way up to 1.75. Okay, now oftentimes we want to include that last item, so maybe we could do something like this, set a step size, h is equal to 0.25, come and put h here, and then do 2 plus h, and now this guarantees that when we get to 2, we're going to include this last number here. So if I run it, this is what we get. Okay, so these are two different common ways to create arrays in Numpy, and we're going to be using Numpy to create an array over which we are going to iterate to solve this problem. When I say solve the problem, I mean solve the problem about the Collatz conjecture that I mentioned in a few videos. There's actually one other thing that I want to mention. AR4, I'm going to say, is equal to numpy dot zeros. And if I just put a number here, it's going to give me an array of length 10, and every item in that array is going to be a 0. So just copying and pasting this. I'm going to change this to a 4. Change this to a 4. If I run it, this is what I get. So all the items in an array are going to be equal to 0. Now, one thing that I don't like is that the default is that it's a decimal or a float meaning decimal in the computer. So I'm going to come up here. There's an optional argument, and I can say D type, that's the data type, equals int. And when I run it, I should get all zeros. And not all zeros, but just integer zeros. Because what I'm going to do, I'm going to create a list. Let's say we want to look at the do this Collatz sequences for the numbers 1 through 10. I'm going to make a list of all zeros of length 10, and then each element of that list is going to correspond to the Collatz sequence for a given number. So I hope that makes sense. We'll see how this goes in upcoming videos.